Well, welcome back. 10.5 part 2. So now we're going to talk about more angles, but now it's going to be kind of outside of the circles. We're still talking about those intersections. So the angles outside the circle theorem. So the angle formed between two lines. So the angle formed between two, like here, like angle 1, 2, and 3, it's being formed by those two lines, is half the difference. So that's what's different from before. Before it was half the sum. We get sums by adding. How do we get differences? Differences comes from subtraction. So these are half the difference of the two created intercepted arcs. So what are the two created intercepted arcs? Well, there's three possibilities. Maybe one line goes through and the other's tangent. They're both tangent, or they're both secant, they both go through. So for here, 1, the angles in question, these are we want to find the difference. Now, we don't want a negative, so we should always subtract the smaller one. So we should always subtract smaller arc to keep our answer positive. So here, the measure of angle 1 is going to be this half of the difference. So the difference would be arc BC minus arc AC divided by 2, or you could put 1/2 in the front. Here, if it's two tangent ones, now something you should notice is that these should add up to 360. So the measure of angle 2 is going to be, again, the big one. So I can't just call it PR because then I don't know. I'm assuming that's the smaller one. So it would have to be PQR, or RPQ, minus PR, half of that. And then finally, you could have 2 that intersect it there. So here's our little one. Here's our bigger one. So in this case, the measure of angle 3 is half XY minus WZ. So half of that difference. So let's use those and try to kind of apply that idea. So here, I want to solve for x. Well, these are my two in question. There's my bigger arc and my smaller arc. So it's the difference of the big one minus the small one, half the difference. So x is going to be 178 minus 76 over 2. That's 102 over 2. So x is going to be 51. So x degrees is 51 degrees. So x is 51. So that's solving for the angle. This one actually gave us the outside angle, and we want to solve for kind of that bigger arc here. So in this case, so the angle is equal to half the difference. So 30 is equal to A minus 44, half of that. So I want to get rid, I can't just divide the 44. Don't do that. All right, so I'm going to multiply both sides by 2 to to get rid of that fraction, and that's going to give me 60 equals a minus 44. Then I can add 44 to both sides. So a is 104. Okay? So that's how to apply that theorem. And then we have the circumscribed angle theorem. But first, let's identify what a circumscribed angle is. So a circumscribed angle is an angle outside a circle that is created by two intersecting, and this is important, tangent lines. So here, it's an angle outside. Say I put it right here. These are created by two tangent lines. So this is that angle in question. You might remember we had a theorem that in 10.2, I think, that if you had two lines like this, or it might have even been 10.1, these two pieces are congruent. So now I'm talking about the angle here. So the circumscribed angles theorem states that the measure of a circumscribed angle is supplementary. Remember, supplementary means adds to 180, is supplementary to the central angle that creates the same intercepted arc. So I have this central angle here. So I have this circumscribed angle, and this is the central angle. So if these were supplementary, let's say this was y, x and that was y, the measure of angle x plus the measure of angle y is going to give me 180. And this is that that intercepted arc I was talking about is right there. So that's kind of the intercepted arc between the two. So let's use that here. So I want to solve for x. So there's that intercepted arc. These two together should give me 180. So x plus 135 is 180. So the value of x is 45. Pretty straightforward. This next one adds something we did in 10.4. So here, the issue is that this is my intercepted arc, but the angle that would create that is here. It's not x, it's right here. So first, we it's 30 plus whatever this is going to be 180. So let's use that. 30 plus what is 180? This is going to have to be 150 degrees. Because if I subtract 130 from 80, I get 150. And now, it's a theorem from 10.4. An angle like this, an inscribed angle, is half the arc. So remember, if an angle's on the edge, it's half of what's outside. So in this case, x is going to be half of 150. So x is 75. So that uses a 10.4 theorem, if you want to go back and look at that. So that is all of 10.5, you can now do your 10.5 homework.